Hello, students, and welcome to Trigonometry. That's exciting.
Isn't that picture beautiful? Look at all that random stuff
It
written down.
is. I bet if someone found or typed in the stuff in the bottom, they'd go to that picture.
It's true. And it's actually something that has like some actual useful stuff. Sometimes when they do this, it's just like
Hmm.
random math stuff written down. But
I've,
this
I've,
is
no- I've noticed that, and I see that there's
actually
some tricky
sorted.
stuff in there too.
Yeah. Although it does say up there the total angle is x plus y plus z equals 180, which is kind of silly, but no, that's okay.
Hmm. Cool. Ooh, there's a fun word.
Shokatoa.
Nice. I like that. Do you think that's a useful thing for students to say a lot, like so katoa?
Yes, but they have to make sure they say it correctly because if they say it
Ooh.
incorrectly, then that will be bad. So they need to spell that correctly.
Is this potentially a problem for people from this area because of accents?
Yes.
I once had a student that had a really, really strong, I think it was more of like a New Jersey, New York accent that did Saukatoa, and you couldn't tell the difference between them, and that was a problem. Uh, but
Why do you think this is written on a page, Mr. Carlson?
Probably because this is a useful mnemonic device to help keep track of stuff. There is a way that I prefer to write this, but I think we should probably talk about some other stuff before I talk about that.
Okay.
Does that make
Uh-huh.
sense?
Yeah, we should just tell them what it means because they have no idea what this means.
So maybe we should write this in the way that I prefer
That sounds good.
as
I
part of
don't know
this.
what that way is, so let's learn. I'm ready.
Um, so before we talk about what this means, I like writing this in a little bit of a shorter way because I like saving space and like combining the letters after the C, the S, and the T, so that it looks something like this. So
Mm.
it's so ka toa. Um, and this is a way to remember these things called trigonometric ratios that are one of the oldest forms of math that we know of. It goes back thousands and thousands of years before any of the other geometry stuff that we do, because some people in ancient Egypt, I think, noticed some really cool relationships in similar triangles. And what they noticed that if we have a triangle that has some specific angles, uh, and in particular right triangles, I'm just going to put an X here because we don't really know what that angle is, that certain relationships were true. We're also going to name some sides on this triangle in some specific ways. I'm going to
George,
go
Betty.
straight across here, and I'm not going to name it George. Since this is a cross, I'm going to call this the opposite side.
Ooh, that's a good one. I like that. Is there going to be a hippopotamus also?
There's a hippopotamus up here. We know that's the hippopotamus, and by that we know we mean the hypotenuse. I was about to write hippopotamus because that's across from the right angle. And the side that's right next to there, we're going to call the adjacent side because adjacent means next to. Um, so what these things mean is that we can find uh, set ratios based on a given angle. So like if this were a right triangle with like a 20-degree angle, the sides would be in a certain proportion all the time. If this were a right triangle with a 36-degree angle, the sides would be in the same proportion all the time. And Mr. Butterworth is circling letters that you might see up above.
I
Uh,
did. I saw those, so I thought those might be important.
and those are really important because we have to define some things. We're going to define the sine of angle X. So it's talking about this angle over here as the ratio of the opposite to the hypotenuse. Hey, do you notice that we've got SOH?
So,
We have another one that's cosine, which has to do with the complement of an angle. That's where the co comes from, but I'm not going to go there right
ooh,
now.
those are the two things that add up to 90, right?
They are.
Oh, I
And
remember that.
cosine of an angle is going to be the ratio of the adjacent divided by the hypotenuse. Oh, look. And then we have a third ratio that we call the tangent ratio. And that's going to be based on dividing the opposite by the adjacent.
Toa.
There's a lot more to
I
trig.
would point to my toe at that point.
Oh, I like
Oh,
that. I see what you're doing there with your toe.
yeah. So I
Uh,
do so for sewing, and then ka like a birdie, and
okay,
then toa you point to your toe.
I like it. There's a lot more to this that we're going to get to later in your math career, but for now, we're really going to focus on these three parts of trigonometry. Ooh, would it be helpful for me to write like SOHCAHTOA up top again?
Yes, and now so we're asked to find the sine, cosine, and tangent for angle t. So if I want to find the sine, now you abbreviate sine sin, and then t, because remember you have to put the angle in there. On the previous page, I made a note. It said angle. You have to put the angle inside the trig
Mhm.
function. You have to have something in there. And then we said it's oa, sorry, o, not oa, o. So that's opposite over hypotenuse. So it's a good idea. I like to circle my angle that I'm talking about and then label my sides.
Can you make an assumption that R is a right angle?
Yes.
Okay.
If you want to label that opposite the right angle, the hypotenuse, opposite the angle T, which I like to make a big loud noise of boo when I fire out that ray,
Hmm.
and it really scares the humans. That's the opposite. And then this is the adjacent because it's touching angle T.
Is it fair that if you do the ones that are a little bit easier for most of us to see, the opposite and the hypotenuse, that the adjacent just kind of falls into place as the other side?
Yes. And then for sine, that would be SR opposite over hypotenuse, ST.
Now, just for notation, I noticed that you did not put bars over those names. Is that because we're talking about the lengths of these segments and not the segments themselves?
Yep.
Okay. So when my students put things without a vinculum or a bar over it, they're talking, yeah, I know I went Latin again. Uh, we're talking about measurements, and that's why I get annoyed when we're calling things by measurements instead of names.
Mm.
Hmm.
But then we also, now back to reality and not Latin, we have cosine of t or cost. And that's the adjacent over the hypotenuse. So the adjacent is RT over ST. Notice at the bottom of the sine and the cosine are the same.
That's interesting.
And then the tangent is the opposite, which is SR over RT. You may notice a connection between your fractions on the right side there. You may not, and that's okay too, but there is a connection there.
Cool. Oh man. So now we have to deal with this with numbers.
Yes,
And it looks like we have to do sine, cosine, and tangent for M for all three triangles.
that is true. It's what it says.
All right, so if I take a look at this first one, again, I'm going to circle the angle I'm looking at, and I'm going to start labeling things. Okay, my right angle's in the bottom. That's kind of weird. So I'm going to put an H up top for hypotenuse. So I'm going to do that HYP, because then when I go straight across, this is my opposite. What's the sound for that? Okay. And I like writing OPP for opposite just because I don't want to like think that's a zero when I write an O. And that leaves me with my other one for adjacent. Cool. So, and I'm also going to write SOHCAHTOA just to keep that in mind. Hey, do you think it's a good idea for students to write that on everything that they do for this
Yes,
time of the year?
yes.
Okay. So sine of M, I know, I like that I put the parentheses after it, is going to be the opposite divided by the hypotenuse. So that's going to be 7 over 25.
That's all I have to do for that? Is just
That
write that fraction
that
out?
is.
Oh, cool.
That's awesome. That's not as scary as it looks. Cosine of M for this triangle would be the adjacent divided by the hypotenuse, which is 24 over 25. And tangent of M is going to be the opposite divided by the adjacent, 7 divided by 24.
Sweet. Now I labeled the next one for them, and hopefully they stop our video right now and they do it themselves. And I haven't labeled the last one because I want them to have to do that part. So you should pause and you should try to finish those two.
Welcome
I
back.
like how we both freeze when we tell them to pause when like allegedly they paused, so who knows? Anyway, so the sine of m for number 12 is the opposite over the hypotenuse. The cosine is where my Wisconsin comes out, is 7/9. And then the tangent is opposite over adjacent, 4√2/7.
So even though that had kind of a scary looking number, the process was exactly the same. And if we don't overthink it, this is not too scary of a thing.
Correct.
Do we want to leave the third one for them entirely, or do we want to show them what that one would be as well?
I think we should just write down what they are and not label the triangle
I like it.
and see if they are okay with that. So sine of m is going to be this. And then cosine is, we work together on that one. And you could reduce these. 2/4 is 1/2. You could reduce these, but for our purposes right now, it's fine.
Yeah, and sometimes it's easier to see connections between things if we don't reduce things.
Yep.
And that can be useful a little bit later in your math. Ooh, this looks fun. So it looks like we're now using some trig, and again, I'm going to write SOHCAHTOA to get some information about angles. And one of the things we mentioned when we started out talking about this is that people noticed that in these triangles that had specific angle measurements, the ratios were the same all the time. And if you were wicked, wicked old, like older than us, so like maybe 200 years old, you used to have to do this with a book that you'd look up like sine or tangent or cosine of 35, and it would give you a decimal. We have lots of technology that helps us not have to do this anymore. And you can use something like Desmos or use your phone turned sideways or use you have to make sure everything is in degree mode. That's a really important thing. If you get lots of negative things for answers in this class, probably not in degree mode.
Yeah, so as we do these, verify with whatever technology you're using, verify that you're getting the same answers, because if you're not, you're in what's called radian mode, which is not what you want to be in. You want to be in degree mode. So if you're looking at your phone, if you turn it sideways, you should be able to see it. It'll either say DEG or RAD. And you want it.
iPhones, I think you want to say the opposite one because it's the button you press and it goes to that mode.
I don't know. You do the first problem and I'll check.
Well, I have my iPhone out, so I'm gonna.
Oh,
So
okay.
I have rad written in the bottom, and if I press it, it turns into rad mode. So if you don't want to be rad, which we don't want to be rad right now, don't press that button. You'll know if you're in that mode because it says rad in the place where you get your answers.
Nice.
Okay.
And on like the TI-84, you press the mode button and you can get changes to degree. Same idea on the Casios. And
Casios are tricky.
I think, you have to do a little bit of work for it, but just Google it and you'll see the directions. Same idea on an Android phone.
Yeah.
As an iPhone, those are similar.
Desmos, if you're using that, you have to press it's not the mode button, but it's like in the top right corner, there's a wrench and you can select degrees or radians. Desmos is really helpful for this because you can type things out. And I like using Desmos a lot for trig. But
so
okay.
how we want to start these problems is we want to identify the pieces we have. So when I look at the picture in number 14, this is the hypotenuse. And then this is the opposite. So I have the opposite and the hypotenuse. You have to pick which trig function to use. Since we have the opposite and hypotenuse, I hope you can figure that out. It's going to be the sine.
So you're saying that because we want x and that's the opposite, and we have 20 for the hypotenuse, we're going to use the one that has those letters O and H, that's sine.
Yep. And then into the sine, we always put the angle. So the angle here is 35. And then opposite over hypotenuse. So that's the basic setup. And hopefully that's not too scary. Now, it's important to remember sine of 35 is just a number. It's just a number. It's going to be like roughly a half, but a little bit bigger. And so I just want to solve for x. So to solve for x, x is being divided by 20. So let's undivide it.
Hmm.
So x is going to be 20 sine 35. And Mr. Carlson said he had his phone out, so he'll figure out what that is.
It's true. So if I were to type that in a calculator, and I'm actually going to do this in 2 steps.
Sorry, I didn't know you were going to write.
That's chill. I'm going to do sine of 35 first, just so that we can make sure that we are on the same mode. I think that's probably a helpful thing. When I did sine of 35 and on a phone, you have to type it backwards. You do 35 and then press sine. I got 0.5376. So when I multiply this by 20, I'm going to use fewer decimals for this part. I've got 11.47.
You said 0.5376, but you wrote 0.75736.
Yep. I
I
don't know which is
assume,
correct because I just went out of that. One of
okay.
those is correct.
I assume what you wrote was correct, but I don't know.
Yep, what I wrote is correct.
Okay,
We're
beautiful.
good.
So for the second one, you want to do the same idea. So you want to, and I always like to circle the angle. It makes me
Yeah,
comfortable.
I do too.
And then I've got the hypotenuse here. I
Ooh, that's weird
don't,
because it's on the bottom.
yeah, I don't have the opposite. That would be the opposite. Pew! But I do have the adjacent. So I have the adjacent and the hypotenuse. So that looks like cosine.
It
So the
does.
cosine, put the angle in, 41, and that's going to be x over 11. So same idea, multiply both sides by 11. So x is going to be 11 cosine 41.
All right, since I've got the calculator out, again, I'm going to do that 11 times I did cosine of 41, and I got 0.7547. When I do that times 11, we end up getting 8.3-ish. Oh, thank you. I never
Great.
finished that statement.
And then lastly, same idea. That's your angle. This is the hypotenuse. This is the opposite. And this is the adjacent. So we don't have the hypotenuse, so that one's gone. We have the opposite and the adjacent. Oh, that's going to be tangent then. Look at that. It has all three trig things. So the tangent of 64 is x over 7. This is the exact same process. You just multiply by 7. So 7 tangent 64.
All right, and when we do that, we get 7 times 2.05, which is close enough. Do that times 7. We get x is equal to 14.35. For future problems, I'm probably not going to show that calculation of that trig value. I just want to make sure that you were in the right mode on this page. Ooh, a word problem. And we have a leaning tower of Pisa. I was going to ask if it was that it was closed. That's sad, but then it reopened, and I learned that in reading this problem. So obviously, math problems teach us all true and important things. Okay, so we're trying to drop an object from the edge and try to figure out how far it from the base it will land. So we're trying to find that value down here. And we're told that we have this angle up here, which is that 5 degrees. I'm going to write that up here so it looks less like it's the side measurement. Okay, can we do the same type of thing here?
We
Where we
can.
label this as the hypotenuse because it's across from the 90-degree angle. Based on this all the way down, I'm not going to draw an arrow because that would just make a mess. That's going to be our opposite, and that would make this vertical side the adjacent.
I like it.
So we're looking for the opposite, and we have the adjacent. That sounds like an OA. Oh, I forgot to write this.
So katoa.
So this is going to be a tangent of 5 degrees is equal to the opposite x over the adjacent 150. And just again, we know we're dividing by 150, so we're going to multiply that to both sides. On the left, we've got 150, tangent of 5, and on the right, we've just got x. So if I were to do that on a calculator, I just did tangent of 150 instead of tangent of 5. That's a different number. We end up getting x is 13.12 feet.
So that means the object would be roughly 13 feet from the base of the tower. I did look this up on the Wikipedia, and it was interesting because it said the tilt got reduced to about 4 degrees, not 5 degrees. And I was like, oh, okay. I don't know why the book used 5 degrees if the Wikipedia says 4 degrees, but I didn't write things, but I was just curious and I wanted things to be accurate.
Interesting.
Now this says your turn, but there are things that I want to talk about on this page.
Ooh, is it because these are a little bit tricksy
Yeah,
compared to
like
what we've
all the
been
ones we've
doing?
done so far have been the exact same, basically. And this number 17 is different, sort of. Like the setup is not different. The setup is the exact same. So you're going to identify your angle, and then you've got your hypotenuse, and your opposite is over here, and then your adjacent.
So I see
You don't
that
have the adjacent.
we're looking for the hypotenuse here. We've got the opposite. That's sine. So
Yes.
that should be the same thing.
Yep. So the sine of 36 is 10, and here's the difference. X is now on the bottom.
Ooh, this looks like some of the proportion problems that we've had to work with.
So it's not scary. In fact, basically, there's only 2 different ways you can set up these equations. So this is the second way. Since the x is on the bottom, I want to multiply by x. I want to multiply by x, and then I want to divide by the sine of 36. Remember that the sine of 36 is just a number. Again, in that case, it's probably roughly 0.6. So then you just do 10 divided by the sine of 36, and you get
X is going to be 17.01. Cool.
Sounds good. Now,
And that
for
makes
number,
sense because the hypotenuse is bigger than the leg.
yeah. So it's good to make sure that things are making sense if you're getting numbers. There's a truck going backwards down my street. I got distracted. But for number 18, they give you 2 different angles. So you get to
Ooh.
choose. Don't get freaked out. You just get to choose. Do you want to use the 28 or the 62? It doesn't matter.
Could we use both?
Yes.
So like if I chose the 28, that's going to make this the hypotenuse, this the opposite, and the adjacent we don't need.
Yep.
So that would be a sine of 28 is 50 over x. Using the same thing we did for the previous one, I'm going to multiply by x and then divide by sine of 28. And I've got x is equal to 50 divided by the sine of 28. And while I type that in, Mr. Butterworth's going to use the other angle.
So, or if I wanted to use the 62, this is not the opposite, it's the adjacent. The hypotenuse doesn't change, but this is now the adjacent. So I have the adjacent and the hypotenuse. So that would be the cosine of 62. And that's going to be 50 adjacent over hypotenuse. So just as Mr. Carlson did, I'm going to multiply both sides by x. So x cosine 62 is 50. And then divide by the cosine of 62. 50 divided by the cosine of 62. And I will bet you $10 that if I put that in the calculator, I would get x is about 106.5.
Yeah, we got the exact same number. One of the reasons that I like to show this is that if you choose something that you think might be the wrong thing, either way you get to the same place. And that's a really important thing with trigonometry because truth be told, if we know the angle that's 36, we know the angle up here too. If we know this angle is 25, we know that angle as well. So we know more than we're given, we can often make some choices. How about we save number 19 for them to try on their own?
Sounds great. So this next one sounds scary, but let's go through the same process. we want to know what x is. Because it says, what is the measure of angle x? We have the hypotenuse and we have the opposite. We don't have the adjacent, but we don't need it. So we have opposite and hypotenuse. So just like before, that's the sine. Into the sine, make sure you put the angle. And then 6/10. Now comes the scary part. And really, this is just a move we're going to tell you what to do because we in our mathematical journey thus far haven't really talked about what we're going to do right now. So we're just kind of going to throw a thing at you without super good context. Is that fair, Mr. Carlson?
Yep, totally fair.
So you want to undo the sign. So to undo the sign, you introduce something called the inverse sign. And now I'll show you why we're doing it. If you do the inverse sign of the sign, that's not a multiplication problem, but I know it looks like one. And then you do the inverse sign of 6/10. What happens on this side is those cancel each other out. So they
It's like
go,
when you multiply and divide by the same thing.
yeah, so it's like 3 times a third. So you just get x. Now, you don't have to worry about that. That's kind of mathematics beyond what we've studied. What you just need to be able to do is you just need to say, okay, x is going to be the inverse sine of 6/10. And to get to that inverse sine, on most calculating devices, you have to do second sine, and that will get you the inverse sine.
And that's going to be 36.86.
Sounds good.
One of the things that I really like to write out a lot is that sine of an angle equals a ratio. Sine inverse of a ratio equals an angle. This is another thing I really like to have on hand for my students so that we kind of get this in our heads a lot.
I like it. So into the sine, I have to put an angle. Into the inverse sine, I basically have to put a fraction.
Yeah, or more likely a decimal based on what we have. We know those mean the same thing.
Yep.
For the next one, I've labeled this already. We've got an A and an H. We're looking for X again, but now we're going to use cosine. So cosine of X is going to be 15/20. We know that to get the angle, we need the cosine inverse of 15/20, and that's going to get us X. And if I do cosine inverse of 15/20, is that another 3, 4, 5?
Yep. It's just the other angle.
So that's going to be the
53.
53 point, I think it's 13-ish.
Yeah.
We get that.
If you're wondering what the 3, 4, 5 thing is, that's a Pythagorean triple idea that we talked about in a previous lesson. 3, 4, 5 is a famous triangle that likes to show up all over the place.
All right, here we're looking for the same thing, looking for y to the nearest degree. Would this be a good one for them to try to set up on their own? Since we did 2 of these.
I think we should do one more for them, and because
okay.
the next page, I believe, has some questions for them to practice.
I like it. So here's our hypotenuse, here's our opposite, and here's our adjacent. Okay, so we've got opposite adjacent, that's a tangent. So tangent of y is equal to 100/41. Is it fair to say that this is a really helpful thing for us to have the students write out the ratio before they try to find the angle?
Yes, you have to show the work here because we need to know that you know what you're doing. So show exactly what Mr. Carlson's showing us. Tangent of y is 100/41. The inverse tangent of 100/41, I would say equals y,
is going to be 67.7 degrees. If a student didn't have access to a calculator, is that an acceptable answer?
Yes, but they should all have access to technology since we're on a computer.
That is true.
That's why I hesitate. I was like, normally, yes, but in the context of now, they should at least be able to use Desmos. Anthony, if you need help on figuring out how to use the calculator, by all means, ask us. So you should try these right now. You should pause the video and you should try these right now.
Welcome back from your pause. So rather than explain these things, I think we're probably just going to write the answers quickly. I'm going to do the bottom two because that requires a little bit of calculator stuff, and I have mine out.
Sounds good. I'll do the top ones once I get to the right page on my iPad. Sine of A. Tangent of A. Cosine of A. Sine of B. Cosine of B. And tangent of B. If you look at mine, you'll notice a pattern going on there. You mean to set anything up, Mr. Carlson, for 7 and 8?
That would be excellent. My calculator just freaked out on me, so I'm going to write that step out. I had extra information in the calculator that I didn't know was in there, and it gave me some kind of weird number.
That's exciting.
That is exciting, and not quite what I was expecting.
All right, friends. So you have to be able to find sides given some information. Well, sorry, you have to be able to write ratios. You have to be able to find sides given some information, and you have to be able to find angle measures. So, ka, toa.
Cool. Ooh. This looks like a fun, slightly more useful problem for those of us that like doing woodworking by hand.
I left this because we love Mr. Regis.
That's
Mr.
true.
Carlson's going to finish this problem off for you.
All right. So if we are trying to figure out how far off the table we're trying to hold this chisel, we are looking at a 30-degree angle, and I'm going to do a really useful thing and draw this triangle separately, which helps us out a lot. I'm going to put my 30 degrees there, and a chisel length that's here, I'm going to put a 6 inches there. How high should the chisel be held off the sharpening stone? So we'd like to figure out what that is. And based on this triangle, we've got an opposite side of x and a hypotenuse of 6. So based on SOHCAHTOA, we are looking at doing this with sine because we've got the opposite and hypotenuse. So sine of 30 is going to be x over 6. And in solving this, that's going to be a half or 0.5. We end up getting 3 is equal to x when we multiply by 6. So when you're sharpening your chisels for woodworking, you should hold them 3 inches off the sharpening stone. That'll be it for today in Trigland. We hope that you've learned some fun stuff about trigonometry.